Right, question number 23. All right, so I want to find the cosine of x minus 1. So I'm just going to do this on a different page just because I wrote some stuff before. So the limit as x approaches 0 of cosine of x minus 1 over x, right? That's what it was. All right, so I gave you a little bit of a hint. Might not have been a hint to some, but hopefully it was. So my hint was multiplied by the conjugate of the numerator. So if I multiply the top by cosine of x plus 1, I'm going to get a cosine of x plus 1 here. All right, so then next thing is when I do that, I'm going to get the limit as x approaches 0 of cosine squared of x minus 1 in the numerator times x cosine of x plus 1. All right, so the next hint was I said use a trig identity. So there's a really important trig identity. It is, dare I say, the most important trig identity. It's the Pythagorean identity. Sine squared of x or sine squared of theta plus cosine squared of x is 1. So if I were to either solve for cosine of x, cosine squared of x would equal 1 minus sine squared of x, or you might even notice that I could have cosine squared of x minus 1 is equal to sine, negative sine squared of x. I can now make a substitution. So I could say that this limit is the limit as x approaches 0 of negative sine squared of x over x times the cosine of x plus 1. Right, so still might not be a good spot. And actually, this we could potentially use L'Hopital's rule now, but we couldn't before. Actually, I'm lying. You could have before as well, right? So you could have used L'Hopital's rule here because we would have gotten cosine of 1 minus 1, which is 0, 0, 0. So that would have worked. But again, I told you to do it with trig identities, not L'Hopital's rule, although it would have worked. All right, so then the thing to kind of note here is that if I have sine squared of x, that really means that I have sine of x times sine of x. So I'm going to pull this negative out for a second because, hey, I don't feel like working with negatives. I have sine of x times sine of x over x times cosine of x plus 1. So because I have two factors in the top with multiplication and two factors in the bottom with multiplication, I can rewrite this in a different way. I can say this is negative still. Limits as x approaches 0, sine of x over x times sine of x over cosine of x plus 1. This is like wonderful news because we know how to handle this thing right there, right? Sine of x over x we know equals 1. So this limit, right, this limit of this product here would be the same thing as negative limit as x approaches 0 of the sine of x over x times the limit of x approaching 0 of sine of x over the cosine of x plus 1. We know that we're going to get a 1 right here, so negative times 1. And then let's do direct substitution. I get the sine of 0, which is 0, over cosine of 0 plus 1, which is 2. So I get negative 1 times 0 over 2, which is 0. So this limit here should be 0.